So you have a low VRAM AMD graphic card? This is hands down the best way to run stable diffusion and generate art on your graphic card. The card I'm using on this video is an AMD RX 570 that has 4 GB VRAM paired with a 10th generation i3 processor, which is popular among gamers who go for budget PC builds. That being said, if you are on a tight budget and wanting to get into stable diffusion image generation, always go for an NVIDIA card with at least 6 GB VRAM. It is the best entry point for this kind of work. All the images you see on this video are generated and upscaled to HD using my 4 GB RX 570 graphic card. I will show you which software is best and how to set that up on your computer. If you find this video useful, make sure to hit the like button and subscribe. Let's get started. There are a few options that works on AMD graphic cards, but the most lightweight and best performing option with less errors was ComfyUI. It can be complicated at first, but you will never go back to other options once you get used to it. First of all, go ahead and update to a recent or latest version of your graphic card driver if you haven't updated recently. Now go to this GitHub page and click on ComfyUI with DirectML. Then click this link and open the Git download page to download Git for Windows. Also download Python 3.10 from the next link in the GitHub page. Setup file is in the very bottom of the page. Now open Python setup and make sure Add Python to Path is checked and click Install Now button. Once the installation is finished, click Disable Path Length Limit button and close the setup window. Now open Git Setup and keep pressing Next button until the Install button appears. Then click Install button and wait for it to finish. Once that is done, go ahead and restart your computer. If you had other stable diffusion installations on your computer prior to this, open the command prompt and enter this code to clear Python cache. Now we are ready to install ComfyUI on your computer. Create a new folder where you want to install ComfyUI and rename it to anything you want. Open the folder and type CMD on the address bar and press Enter. It will bring up a command prompt in your new folder. Copy and paste this command from the third step in the GitHub page and press Enter. It will start downloading ComfyUI files. Now go ahead and download the batch file from the video description. Open that using Notepad and check if it has these parameters set properly. We'll copy that file into your ComfyUI folder that we created earlier. It should be on the bottom of the folder. Before you run the installation, go ahead and download a checkpoint model from Civet website first. I would recommend you to use a Stable Diffusion 1.5 model because it is generally recommended due to its efficient memory management. However, you could use these Flux 1 Dev models displayed on the screen as well. But I only use Stable Diffusion 1.5 for testing and creating all these images. Now open the model folder and go to Checkpoints folder and paste your downloaded model file. Now go back to the batch file we copied earlier and run it. A command prompt will open and start installing ComfyUI. It will take some time. Wait for it to download everything. Once it has finished installing, you might get an error like this. Just press OK. If everything went well, you should have this web address displayed in the command prompt. We'll copy and paste that into a web browser and it will load the ComfyUI interface. You might have a different looking workflow than mine, but don't pay attention to that yet. I would recommend going to Settings and changing the menu layout like this, and then you can drop this button on the menu bar if you want. Then close the command prompt again. Now go ahead and navigate to Custom Nodes folder and open a command prompt by typing CMD in the address bar and pressing Enter. Copy and paste this other code from the GitHub page and press Enter to install the ComfyUI Manager. This is needed to install custom nodes into your ComfyUI installation, and we will be using this a lot. Once that is done, you can open ComfyUI again, and it will download the packages required for ComfyUI Manager. Once it's all done, you can open ComfyUI and start generating images using a basic workflow like this. You can check the progress of the generation process using the command prompt that is running in the background. I will give you a couple of basic tips to follow when you are running ComfyUI on a low VRAM graphic card. When you generate with Stable Diffusion 1.5 models, start with a resolution that is close to 512 pixels to get the best results. I have few recommended resolutions displayed in the screen for different types of images. You can upscale them twice the size to get more details and clarity later. If your graphic card is crashing during generation process, go ahead and lower your base clock speed a little bit and consider setting a higher fan speed for higher temperatures. You can usually increase the VRAM clock speed a little bit without running into problems. It all depends on the conditions of your graphic card and other factors. You can play with these settings and experiment on what works best for you. Also consider closing all the other apps you aren't using to free up the RAM. I have 16 gigabytes of RAM on my system where I generated all these images, and usually it uses all the RAM to load models. So I guess you would need at least 16 GB RAM to properly run it. Now I will show you how to make a simple workflow to generate images and upscale them with built-in nodes on ComfyUI. The first node you want is the checkpoint loader. This node is where we select the AI model we downloaded from Civit website earlier. If you have downloaded multiple checkpoint models into your checkpoint folder, all of them will show up and you can select one from the drop-down list on the node. Next thing you need is a K-sampler. This node is where we do most of the image generation process. And connect the checkpoint to K-sampler with model dots. Then go ahead and add 2 clip text nodes for the positive and negative prompts. You can connect them to the K-sampler as well. I usually like to color them green and red to recognize them easily. You can position these nodes that is most comfortable for you. There is no correct way to positioning them. The next node you need is an empty latent image. This is basically an empty canvas for the AI to draw on. You can enter image size you want to make and connect that into the K-sampler. These AI models can't understand normal images, and they work with latent images. So the output generated by the K-sampler is a latent image that we can't understand. We have to decode it with a VAE decode node. It's a good idea to use a tile VAE decode and encode nodes when you are working with limited VRAM. Make sure to connect the VAE dot from the checkpoint model or VAE model loader. You can save this decoded image using a save image node. The first image we generate sometimes can be low quality. It's always a good idea to run it through another K-sampler to get more details and upscale it a little bit. I'm going to show you a very basic method of doing this. This will give you good details and fix most of the errors in the first image we generated. Add a new node called Upscale Image By. It's a good idea to upscale by 1.5 or 2. And I like to use the upscale method called Lanczos. You can experiment with these and find what suits you best later. Then we have to encode this image back to latent so the AI can understand it. I'm using a tile VAE encoder for this again. Make sure to connect that to the VAE model. Next, we need an advanced K sampler. All these nodes are available on ComfyUI out of the box. You don't have to install any of these nodes separately. Make sure to connect the model. Positive prompt and negative prompt were used earlier into this as well. Also connect the latent image we got from the upscaled image. Finally, run the output latent image we get from the advanced K sampler through another tile VAE decode node. Make sure you are using a tile decode at this point, because the normal decode node might run out of VRAM due to the fact this is an upscaled image. You can use the Save Image node to save this one as well. You can add a prefix name for better organizing these save images. This is a complete workflow for basic text-to-image generation. Even though this is not the best method of upscaling, it will give you a decent-looking image with good details. Make sure to set seed generation to fixed, and use the same seed for both K samplers. Set the number of steps to 30 in the advanced K sampler. Also set the starting step to something close to 25 and end step to 30. You can go a little bit lower on the starting step if you want. Now I'm going to enter a positive and negative prompt that I prepared earlier. You can find how to write these prompts and prompt examples from the model page on Civit website you downloaded the model from. Finally, press the Q button to start the generation process. It will take a while depending on your graphic card. It usually takes 5 seconds per step for the first generation and 20 seconds per step for the 2x upscale process on my RX 570 card. If you look closer, the upscaled image looks much clearer and natural than the first generation. You can find all the links to the guide on the description of this video. Don't forget to leave a comment if you have any questions. I hope this will give you a good starting point to get into AI image generation. I will also be making more videos about everything related to generating images on low VRAM graphic cards, such as other upscale methods, control net, face detailers, model reviews, special workflows, and much more. My next video will cover all the ways you can use Hires Fix and get better upscale results on low VRAM graphic cards.
Alright guys, make sure to help me out by liking the video and subscribing to my channel if you want to see more awesome videos like this. Thanks a lot.